Okay, so just now what we went through was your different formulas for your three different shapes that we learned today. Your pyramid, your sphere, as well as your cone. Okay, this next portion, okay, just now I mentioned you have something called slant height in your formulas, right? So this is where we have to make use of your Pythagoras theorem you have learned before. Okay, to find your slant height of your pyramid or your cone. Okay, so if you all remember for Pythagoras theorem, it only applies for right angle triangles. Okay, only for right angle triangles. Okay, so if you look at the example given to you of a pyramid, okay, so this is a square pyramid with a square base. Okay, so if you look at the pyramid, this length or this vertical length here, okay, this is what we call the height of your pyramid, right? From the tip of the pyramid to the center of the base. Okay, so if this is a vertical height down, naturally this would be a 90 degree. So if this triangle, which is a replica on the side, okay, this is also 90 degree. Okay, so if you read the question, it's a right angle triangle. So the slant height is 10 cm and the base is 4 cm. Okay, given to you by the question. So 10 cm because this is given to you. How did I get the 4? Remember I mentioned for your base, okay, the point here, this is your epicenter or the center of your base, which means it's half the length of it. That's how you get 4. Okay, then from there to find your height. Okay, you can put here h. Okay, use your Pythagoras theorem and you work it out. Okay, and you realize they leave it as square root 84 here. Okay, put a cm in. Okay, nothing wrong if you key out your square root 84 into your calculator, but you realize you get a very ugly decimal. Okay, so in mathematics, you try to be exact as possible. So we can leave it in this perfect form of square root 84. After that, when you apply it into a formula, you just throw in the square root 84. Okay, it makes our lives a lot easier. I don't have to write in so many decimals. Okay, then you key in the calculator, write the 5SF value, okay, followed by the 3SF value. Okay, make this a habit. Okay, because sometimes in questions, you might need to use the answer again. Okay, so as a habit, just write the 5SF value first, followed by the 3SF value. Okay, this is how you apply your Pythagoras theorem to find slant height. Okay, this is for your pyramid. Okay, now we look at your example for Pythagoras theorem for a cone. Okay, so you have a solid in the figure below that is made by extracting a circular cone from a metal hemisphere. Okay, so metal hemisphere, the hemisphere is a half a sphere. Okay, diameter 20 cm. Okay, calculate the volume of the figure. Okay, so naturally, volume of the figure will be the volume of the hemisphere minus the volume of the cone, right? So volume of the hemisphere 2/3 pi r cubed. Okay, because the diameter is 20. Okay, so radius is half of the diameter, 10. Okay, just throw in your values. Okay, for your cone, 1/3 pi r square h. Okay, the h is already given to you as 8 cm. Okay, the radius here is 6. Okay, that's how you get the values. Throw in the values. Okay, key in your calculator. Okay, then you get your 5SF value followed by a 3SF value. Okay. However, if you're asked to find the total surface area of the figure. Okay, so the total surface area of the figure, essentially, you have to take into consideration, obviously, the curved surface area of the hemisphere, right? Together with the curved surface area of the cone, because inside the cone as well. Okay, as well as lastly, what you have is this portion here. Okay, the non-cut-out portion of the base of the hemisphere. Okay, these are the three portions that you need to take into account. Okay, so if you take a look at what you have already, curved surface area of the sphere, hemisphere, no problem. Then the surface area of the base, also no problem, because you have what you need. The only thing you need to work out is the slant height of your cone, because you need that to calculate your curved surface area of cone of pi rl. Okay, that is why you make use of your Pythagoras theorem. Same thing as well. Okay, if you look at your cone here, this is a right angle triangle. Okay, so if I draw the triangle for you, okay, radius 6, height 8. What is this slant height? Okay, so essentially this slant height is what I need to find. Okay, that's why they found the slant height of the cone. Okay, you get 10 cm. Okay, after that, you throw everything into what you need. Okay, total surface area of the cone, 2 pi r square, because half of a sphere. Okay, so 2 pi r square for the curved surface area of the cone. Then this pi times 6 times 10. This is your pi rl, curved surface area of cone. Okay, sorry, this was hemisphere. I think I said cone just now. Okay, then lastly, you have pi times 10 square minus pi times 6 square, which is this region here. So that means you took the base area of, this is the base area of hemisphere. This is base area of cone. Okay, work it out. You get 1020 cm square. Okay, this is how you apply your Pythagoras theorem to both your pyramid as well as your cone.